All right, guys, here we go. Here we go. We're gonna continue with trig. So, and I think you'll like today's lesson. We'll see. So it's the same deal with that last time, guys. I call this the Valentine's formula. It's not really the Valentine's formula. It's a Pythagorean identity. Cosine squared plus sine squared equals 1. Remember that squared there. So side note, cosine squared x, that means parentheses cosine x, close it with a squared. So that means cosine x times cosine x. Sometimes if you put the squared immediately, then that means that the x that's being squared. Of course, there's always a big debate. There was a fight on Facebook with calculus teachers. So make sure that you put the square there after the s. How do I use it? Like this. If you say cosine of pi, I guess let's write cosine squared. If I write cosine squared of pi over 6, I'm not necessarily using this formula. I'm just typing what that is. So that means what's cosine of pi over 6? Everyone at the same time. Square root of 3 over 2, and then close it, put a square on it. See? So square root of 3 times square root of 3 is 3. 2 times 2 is 4. That's how you use it. So hopefully we know that. Cool or not cool? Cool. Same thing with 1 plus tan squared. We already talked about it. There's two different ones that you can write from that, right? You can move the tan squared to the right, and you get secant squared minus tan squared. You can move the 1 to the right and leave the tan squared alone. Tan squared equals secant squared minus 1 squared. You can even flip-flop the tan squared and the secant squared, and you'll have 1 minus secant squared equals negative tan squared. It doesn't matter. Cool or not cool? Okay, so now I think we're good. This is just the same thing over again. So let's talk about even and odd functions. What's an even function? What's an odd function? An even function is symmetric about the y-axis. Think like parabola with the vertex on the y-axis. So I'm going to write even is symmetric about y-axis. And it has this property, f of negative x equals f of x. So for example, if I have f of x equals x squared, we all know that's an even function. And I were to type f of negative x and see if we get the same thing. Parentheses, negative x, close it squared, and OMG, negative times a negative is a positive, and then no, there it is, and notice that you get x squared also. So that's an even function. So what is an even function when it comes to trig? Well, cosine x. Cosine x goes like this. See? And it's split right down the middle there. So if I tell you f of x equals cosine x, and you wanted to see if that is in fact the same, then your f of negative x equals cosine of negative x, which is cosine of x. Child, I don't see it. Well, let's see. Test. Cosine of negative pi over 6. See, the unit circle doesn't go away. Cosine of negative pi over 6. Do you guys know what that is? Yeah, square root of 3 over 2. I heard someone say it. And then check it out. If I type cosine of pi over 6, you also get square root of 3 over 2. That's when you do the arc inverse or arc cosine of square root of 3 over 2, you get plus minus, that you put the plus minus in the front, plus minus pi over 6. So there it is, guys. So all this in red is even. And what else is even? So this is even. If cosine is even, sorry, next time I'll mute this. If cosine is even, then also its inverse, its reciprocal is even. What's the reciprocal of cosine? Secant. F of x equals secant x. So f of negative x is secant of negative x, which also equals secant of x. So everything in red there is even. Are we still okay? What is odd? Well, odd looks like this in blue. Let's do this function. That's an odd function. That's odd. It has this property, f of negative x equals negative f of x. And that negative is in the front. See? So, what's going on here? If you have, let's say I have a function like f of x equals x cubed, and let's say I plug in a negative in here, f of negative x, parenthesis, negative x, close it, cubed. Negative times a negative times a negative is a negative, and you have this. If you want to do this, put parentheses on that. OMG, it's the same. See? That is negative f of x. as f of x was x cubed. I got to be careful because I made f of negative x there. If I make f of x equal to x cubed, see, that's just negative of that. So this is odd. Symmetric about the origin is how you say it. Don't worry, guys. Right now we'll get more exciting. Symmetric about origin. Chop, does it have to go through the origin to be an odd function? Yes. Yes, you do. Now, later on, there's going to be some functions when we start doing algebra that have odd tendencies, like end behavior. But for it to be an odd function, it must go through the origin. Cool or not cool? All right. So what's an odd function? Well, sine. I know. I'm taking up all these notes up here. Sine looks like this, guys. See? So what's an odd function? Y equals sine x. That's an odd function. If sine is odd, its reciprocal is odd also. Cosecant x and tangent. Tangent's odd as well. Y equals tan x. And if tangent's odd, then its reciprocal is odd as well. Y equals cotangent x. All those are odd. Sorry, guys, that I wrote it up there. All right. I'll slow down. Are you guys tired? No? Yes? Yeah. I took a little nap. I think I fell asleep for like 10 minutes. All right. What about when sine, cosine, tan are squared and I have a negative argument? So that means this. I know for cosine, I guess it doesn't matter because cosine's an even function. So if I go cosine squared of negative pi over 6, well, we already know cosine's an even function. That's the same thing as cosine squared of pi over 6. This one's fine. You don't care about that one. What do we say that was? Square root of 3/4? I think I wrote it. Where did I write that? Yeah, right there. Yeah. Square root of 3 over 3, but 2, then you square it, right? So 3 over 4. Square root of 3. Okay. See, yay. Okay, now check it out. So I guess for the cosine, you don't care. Cosine negative theta is the same thing as cosine squared theta. But for sine, look what happens for sine. And I know what we said over here, chop. Over here you said sine of negative theta is negative sine theta because it's an odd function. Now you're changing things on me? No, relax. Sine looks like this. Why? When you square it, negative times a negative is a positive. So look what I'm doing here on the side. If I write sine of negative pi over 6, yes, I get it that it's negative half. Sine of pi over 6, yes, I get it, that's a positive half. But if I put a square, that means I'm squaring this, and I get 1/4. If I put a square right here, that means I'm squaring that, and again, I get 1/4. So do you see how it doesn't matter? Chop, what do you mean it doesn't matter? The sign in the argument doesn't matter because you're squaring it. It's going to be positive anyways. So we have this statement. Does that make sense, guys? Same thing goes with tan. Tan squared of negative theta is going to be the same as tan squared of theta. The same thing goes with all the other ones. Secant squared of negative theta is the same as secant squared theta. Cosecant squared of negative theta is the same thing as cosecant squared theta. It doesn't matter because you're squaring it. Negative times a negative is always a positive. Don't become a robot. I know some of you are getting like really tired and you're going through fumes and you're probably not even listening. Try your hardest, guys, to stay focused. Math, next year we'll have math in the morning, and math in the morning is a lot better. It's not even first period. It's going to be second period, hopefully. Second period is the perfect time to do something you want to learn because you're not tired yet. But in the evening, you guys are already tired. How do we feel? Okay, go to the next page. What identities should you know stone cold? No matter what, that you're taking them to your grave. You should know stone cold the Valentine's formula. What is it? You should know that one, guys. Know it. Know it, no matter what. What else should you know stone cold? Well, if you do a full revolution on the unit circle, you're back at the same location. So we should know that for cosine and sine, if I have an angle and you add 2 pi, that's still going to be the same thing as cosine of that angle. Same thing for sine. Sine of theta plus 2 pi, it doesn't matter. That's going to be the same thing as sine theta. Chop, why are you showing us this? Because you're going to see these. You're going to see these later on. For tangent, the period for tangent is pi. So for tangent, theta plus pi is the same thing as tan theta. And I guess if you wanted to, you could put an n there, where n is an integer. But I'm just going to leave it like that. Are we okay? You know what? Now I want to put the n. N, N, N. N is an integer. Integer is a whole number. 1, 2, 3, 4, 5. I'm not going to say the last two or the next two. How do you feel? ¿Cómo te sientes? Did I say how do you feel in Spanish, or did I say how do you sit? ¿Cómo te sientes? How do you sit? That's how you say it, right? Okay. Not that you would say that, but okay. Tough crowd, tough crowd. Okay. Are you guys okay? Next. Okay, you know what? Something else that we should also know called cosine theta is even. Sine theta is odd. What else should we know called? Tan theta is equal to sine theta over cosine theta. Cotangent theta is equal to cosine theta over sine theta. Secant theta is equal to 1 over cosine. And cosecant theta is equal to 1 over sine. All that we should know colds. All right, guys, I tried to fit it in there. We're still okay? Okay. Cosine and sine differ by a phase shift of pi over 2. Child, what does that mean? That means that if I go to Desmos and I grab cosine and sine, Desmos, and I should, let's put good habits. Sometimes you got to just put, all right, there's cosine, there's sine. Do you guys see the blue and the red? This peak is at 0. This peak for the blue curve, that's a sine curve, is at pi over 2. Well, yeah, sine of pi over 2 is 1. See how they just differ by pi over 2? If I move this blue curve pi over 2 to the left, it'll be that red one. Or if, conversely, if I move that red one pi over 2 to the right, it'll be that blue one. So you can just write this. You can say, I can say this. What does that mean, Chop? That means I can say, and this is just for convention. I know some of you are probably going to say, why can't I just say x minus pi over 2 or whatnot? They want a uniformity, so I'm going to write it like this. I'm going to write sine, and I'm going to write pi over 2 minus theta. And then the same thing can be said about sine. Sine theta equals cosine pi over 2 minus theta. Chop, I don't believe you. Well, let's see. I come over here. I take Desmos. You can also do it in a T84, but today's we're not using our calculators here. So here is cosine x. Let's put a parenthesis, and look, check it out. I'm going to put sine x, or sine pi over 2 minus x. Oh, look at that. It's the same curve. Look at the purple. Look at the green. Can you guys see the difference between, I guess if you're colorblind, you might not be able to see that. But there's green, and then look. Cool, right? Or not cool? Okay, look at the next one. What did we just test? We tested the cosine. So y equals sine x. And then look at this. There's my sine x. Y equals cosine, parenthesis, pi over 2 minus x. Oh, look at that. It's the same graph, guys. Look, I'm going to turn off the red one. There's sine x. And then when I push this one on, look at that. It's the same. Isn't that cool? So now you know some more properties. We're going to be using those to derive double and half angle properties soon. So there it is. What does that mean? That's what it means. Yay or nay? Okay. Yay. Guys, come on. All right. Here we go. Finally, we have enough background knowledge that we can start tackling these questions. Y'all ready? All right. Which of the following is equivalent? Notice the argument, that's why you call this in parentheses. All of them are positive but one. So more than likely, we're probably going to have to turn these negative thetas into positive thetas. I know that sine of negative theta, sine is what type of function? Odd or even? Odd. Because sine is odd, I know that this is equivalent to negative sine theta. What about, let me put the word odd here. What about cosine? Cosine is even, so cosine negative theta is the same thing as cosine theta. Are we okay? We're going to sub. So here we go. Sine negative theta, I'm going to put a negative on the outside. Negative sine theta over cosine negative theta. I'm going to just type in cosine theta. I don't see sine over cosine, but I know that sine over cosine is the same thing as what? Tan. So keep the negative. Yeah, you guys can be strong, guys. Be courageous. There it is. Negative tan theta. Do I see a negative tan theta in there? There it is. How do you pronounce that argument? It's a theta. If you see this, that's a beta. If you see this, that's a alpha. If you see this, that's a phi. Sometimes people say phi. What else do you guys want to know? Tilde? What other Greek symbols do you guys want? Okay. All right, let's go to the next one. Are we okay? All right, which of the following is equivalent to cosine squared over 1 plus sine theta? When you see this, guys, here's what you should be looking. You look at the answer choices. Do you see any of these answer choices with cosine in them? No. So then we're probably going to be substituting something for that cosine squared. So the first thing you're going to say, well, what do I know? Because what do you guys know? You know the Valentine's formula. Cosine squared theta plus sine squared theta equals 1. We know that, right? All right. Move the sine squared to the right. Cosine squared theta is equal to 1 minus sine squared theta. And OMG, I'm going to substitute that. So I'm going to type this 1 minus sine squared in for that cosine squared. So I'm going to go 1 minus sine squared theta over 1 plus sine theta. Don't cancel anything. Nothing cancels. Okay. I'm going to bring it up because on your handout, I saw a lot of it. Side note. And I'm not mad. I'm not annoyed. Can I cancel anything on that? No. Don't tell them. Can I cancel anything on that, guys? No. Why can you not cancel?
Because you're adding the numerator. You can't cancel anything if you're adding or subtracting the numerator or the denominator.
Yeah, it needs to be an inverse operation, guys. Some of you are doing this. No, don't. That is not a thing. It needs to be an inverse operation. Play with numbers. Do this. 3 plus 4. Well, 4 plus 3, 4, 5, 6, 7. That's 7. You're telling me 7 divided by 3 is 4? Like, it's not. It's not. Inverse operations, multiply and divide, that you can do. So if it was this, 3 times 4 divided by 3, now that you can do. Why? Because you have a product on the top, and you're dividing. Multiplying and dividing are inverse operations. That you can do. 3 times 4 is 12, divided by 3, OMG's, back to 4. See, so that you can do, that you can cancel. So another problem that I saw with you guys, and I'm not bashing all of you, and I'm sorry, don't get offended. A lot of you were, oh, a plus b squared, oh, that's a squared plus b squared. No, it's not. Play with numbers so you can see. 3 plus 4 squared. You're telling me that's 3 squared plus 4 squared. Well, let's see. 3 plus 4, that's 7. 7 squared is 49, guys. 3 squared is 9. 4 squared is 16. 16 plus 9 is not 49. Like, do you guys see what I'm trying to say? So, yeah. So a plus b squared, if you must know, or a plus b with a square on it, is a squared plus 2ab plus b squared. That's what it is. Yeah, it's got it. All right. Cool or not cool? All right. Sorry, guys. I had to say that. Side note. Nothing cancels, but the top is the difference of squares. 1 times 1 is 1. And sine theta times sine theta is sine squared theta. Do you guys see that? Sorry, guys. I need to know how to turn this thing off. I have my phone on silent, but I don't have this thing on silent. All right. The top, the numerator. Difference of squares. 1 plus sine theta times 1 minus sine theta all over 1 plus sine theta. I put parentheses on the bottom to help you out, but initially it was like this. In case you don't understand, Chav, I have no idea what you did. Guys, if you follow this out, you'll get the 1 minus sine squared. Look, don't write this down, just listen. 1 times 1, that's 1. 1 times negative sine, that's negative sine theta. Sine theta times 1, that's a plus sine theta. And then look, positive sine theta times the negative sine theta, that's a minus sine squared theta. Look, these middle terms, they just zero out. 1 minus sine squared theta. See? So there it is. Now that I have it looking like this, the top is a product. I'm multiplying. And if you group these two terms, if you want to put parentheses on them, what can I cancel? Now you can. What can I cancel, guys? Yeah, 1 plus sine theta. Bam! You can call it a binomial if you want. You can cancel the binomial 1 plus sine theta. But really, that's more, well, okay. I don't want to go into technicalities. So there it is. So my answer is 1 minus sine theta. Do you guys see how we did that? Yee? Yee. Okay. Can we take some more? Okay. Are you not entertained? You're so tired. Hello, so tired. Oh, stop. That was not good. Tough crowd. All right. Here we go. You guys ready? No? Focus on this cosine x plus 2 pi. If I have x plus 2 pi, that's the same thing as cosine x. Yeah, cosine x. What about this sine x plus 2 pi? Same thing as sine x. So let's rewrite this. Cosine x over sine x plus sine x over cosine x. I don't see that answer choice and for A, B, C, D. So how do I add two fractions? Common denominator. I want to multiply the left fraction by, yeah, make sure you write cosine x over cosine x. Some of you are just writing 1 cosine x. You got to make sure that you write cosine x over cosine x because that's 1. Anytime you multiply by 1, it's itself. The right one, you multiply by sine x over sine x. Hey, Doña, that's a demerit. I'm sorry, miss. Sorry for your demerit. Are we okay? All right, here we go. What's cosine times cosine? Cosine squared x over cosine x sine x plus, what's sine x times sine x? Sine squared x over cosine x sine x. If you don't like the square there, put sine x in parentheses and put a square on the outside. That's fine. You don't have to do 2 lines like this. If you already know what you're doing, you can do it in 1. The denominators are the same. Go ahead and just write 1. So cosine squared x plus sine squared x all over cosine x sine x. Estamos bien. Canilon, you son. No, I just said gibberish. I didn't say anything. That answer's not in there. What do I got to do? What is cosine squared plus sine squared? 1. This is 1. This is 1, guys. So 1 over cosine x sine x. And if you see it from here, that's fine. But if you want to separate it, okay, well, look. 1 over cosine x. Some of you put up a plus symbol. I have to take out points. Times 1 over sine x. That's a product, guys. What's 1 over cosine? Secant. What's 1 over sine? Cosecant. Okay, and I'm going to bring up something else that you guys are doing. And I took off points, and I had to because you guys keep doing it. Not everyone, just like 3 or 4 of you guys. Notice that all of my sines and cosines, all of them have an argument. Chop, what does that even mean? All of them have an x or a theta or something. Cosine does not go by itself, guys. Some of you are going cosine. Guys, that's not a thing. That's not a thing. If you do that, they're gonna kind of wrong because it's not a thing. It's like ln. Ln is not like you gotta have ln of something, guys. It needs to be a something. You don't see f. You see f of x. So you got to have an argument. You got to put your variable in there. So stop with just sine, divide by sine. It's sine of x or sine of theta or sine of alpha, whatever the argument is. You guys know what I mean? Okay. And I hope I've been doing good habits. Look, everything has a theta. Everything has an So stop. When you guys do your handout, stop. You guys just put an argument in there, guys. Don't worry, I'll pass out y'all's work in a little bit. Okay, the last one. I will just say this with this last one. The more experience you get, the easier it gets. If you just go into it cold turkey, of course you haven't done enough of these. Of course it's going to be hard. So you know what? Put your pencils down. Just don't worry. I will leave it up there so you guys can write it down after the fact. I just want you guys to observe like the logic and how we're going to do it. All right. Does everyone have their pencils down? All right. So I'm going to focus. Let's see. Which one looks more entertaining? I'm going to focus on this one right here. Chav, why are you focusing on that one? That's the one that looks more entertaining because that's the one that has the cosine cube. This just has secant, 1 over 1 minus sine. I can handle that. But do you see the cosine cube? That's different, right? So that's the one I'm going to focus on. So don't worry. I'm going to give you guys time to write. Just focus on for a little bit. So I'm going to write the word focus. In a little bit, you can write all this stuff down. So step 1, I'm going to focus on that. And I'm going to write 1 plus sine theta over cosine cubed theta. And I'm going to say, well, I don't know anything about cosine cubed, but I know about cosine squared. And I know my law of exponents. So I'm going to write 1 plus sine theta over cosine squared theta times cosine theta. See, here's why your algebra comes in. Side note. You got to know x cubed is the same thing as x squared times x. See? So you got to know your algebra. If your algebra is weak, we're going to have a hard time. Are we okay? And then we say, okay, well, what do I know about cosine squared? I know that cosine squared theta plus sine squared theta equals 1. You guys know that, right? So then I'm going to move this sine squared to the right. So I know that cosine squared theta equals 1 minus sine squared theta. All right, guys. Cruz, hello. All right. So I know this much. Are we okay so far? All right. I'm going to replace it with that cosine squared. So I'm going to write 1 plus sine theta over parenthesis 1 minus sine squared theta times cosine theta. Don't worry, I'm going to give you guys time to write. Not yet. I'm even labeling this. Second step here. Are we okay with step number 2? Okay. Now that I got it to here, I see the 1 minus squared and I think, well, look, I have a 1 plus sign in the top. I can expand this one because it is like the difference of squares, just like we did a little while ago. Sine theta to sine theta. So I'm going to go 1 plus sine theta. I'm going to call this step 3. Over parenthesis 1 plus sine theta times 1 minus sine theta times cosine theta. There's my product right there. Do you guys see that? Now that I have it looking like that, what can I cancel? Yeah, the 1 plus sine theta. If you want to put a parenthesis there, you can. Bam, bam. Step 4, collect it. So here it is. I'm going to rewrite it. I have a 1 in the top, and I have 1 minus sine theta times cosine theta. Do you guys see that? Now that I got it to look into this, I'm like, okay, I feel good now. I'm going to go ahead and write the word rewrite, and I'm going to bring everything together. So, and don't worry, I'm going to give you guys time. So I'm going to write secant theta over 1 minus sine theta minus whatever I have over here, number 4. 1 over 1 minus sine theta times cosine theta. Does all this make sense so far to you? All right. And then I look at it finally, and now we're getting close. Don't worry, I'm going to let you guys write a little bit. And I say, well, I can almost subtract them. To subtract them, I need to find a common what? Denominator. So all I got to do is take this left one over here and multiply that left one by cosine over cosine. And then look what I have. So now I'm going to write step number 6. I'm going to have cosine theta secant theta over, I guess I'll write it like this one. 1 minus sine theta times cosine theta minus 1 over 1 minus sine theta cosine theta. And then since both the denominators are the same, I'm going to group them and I'm going to write it like this. Cosine theta secant theta minus 1 over 1 minus sine theta cosine theta. Did that make sense? Okay, last. We're almost there, guys. We're almost there. I see this secant theta because, the cosine and sine are the favorites. Secant theta is not necessarily the favorite. And I write, well, I know from my notes last week that secant theta is the reciprocal of cosine. Or I guess you don't have to do that. You can just know it and just cancel it right there. So because secant theta is the reciprocal of cosine, these two, when I multiply them, is just what? 1, yeah, it's just 1. Do you guys see that? And just in case you don't see it, I'll write it. Cosine theta Look, cosine theta times 1 over cosine theta. They just cancel out. Just 1. Cool or not cool? What is 1 minus 1? So I have a 0 in the numerator. 0 divided by anything is all that for 0. Do you see how we did it? All right. Can you guys see? Did I leave no space? Okay. That's a 0, by the way. It just looks like a happy face, which it is, but there's a 0. By the way, if you have something like that with a line through it, that's a null, which is not a 0. That's an empty. That's empty. I guess there's also something called empty set. Have you guys taken number theory? Of course not. But have you guys heard of these things? No? Okay, then forget it. Yeah, the number 0 is quantity 0, and the null is like empty character, nothing there. In programming, it's a big deal, but in the math world, they interchange them. All right. Let's have a quick chat. We're getting pretty close to wrapping up section 2 of unit 3. We haven't exhausted, like we haven't done a whole bunch of problems, like application problems. I feel like we still need to do more of those. But we're getting ready for a test. At the moment, it's subject to change, of course. At the moment, I have a test set up for 1029. Maybe we'll move it forward. I'm not sure. But this is not being moved. It says here, attempt UH trig identities. I want that attempt today, guys, because I like to put it on gradebooks. But attempt it today if you can. And then when is it due? The 28th. Is that enough time to get it to 100? Yeah, and you can ask me questions, not when you're live, but you can ask me questions on how to perfect it. There is a delta. Hold on, relax, hold your horses. There is a delta. It should take you approximately 15 minutes. It's only one subtopic. And so maybe do the delta first so you can get warmed up and then do the UH. Is that cool? All right, guys, give it a shot. We're done.